Shapes of molecules is one of the typical questions in paper one as well, but they can come embedded within other questions, not like a big question in A-level paper one. So in a shape of molecules, the thing that you need to know about is that the shape will depend on the number of bonds and the number of lone pairs of electrons around the central atom. So the remember that the shape of the molecule is governed by these two factors, number of bonds, number of lone pair of electrons. The idea is that the pairs of electrons are trying to stay at further apart from each other in space. So they will keep away from each other and take that shape. And then when we have lone pair of electrons, the repulsive power between the lone pair will be more than the repulsion between the lone pair of electrons and the bonded pair, which is more than the repulsion between the bonded pair and bonded pair. This is according to the valence shell electron pair repulsion theory. So the shapes of molecules, you need to memorize these ones. Okay, so these ones, because you're gonna identify based on the shape they're gonna give you, you're going to calculate the number of bonded pairs, number of lone pairs, and then you need to say what is the shape, what is the bond angle. So if you have two bonds with no lone pair of electrons, the shape is going to be linear and the angle is 180. And if you have three bonds and there is no lone pair, the shape is trigonal planar and the bond is 120. If you have four pairs, if we have four pairs, and these are as four bonds and no lone pair, it's going to be tetrahedral with a bond angle of 109.5. But if you have four pairs, but three of these are bonds and one is a lone pair, then it's going to be trigonal pyramidal, and the bond angle is 107. If you have two bonds and two lone pairs, again, then in total there are four pairs of electrons, but two bonds and two lone pairs. The shape is called bend, or you can say V shape. The bond angle here is 104.5. Notice the difference in the bond angle between the three. The bond angle keeps decreasing as we go to the right, as the number of lone pairs increases. This is because what we said about the repulsion between the lone pair is higher than the repulsion between the lone pair bonded pair, which is more than the bonded pair. So the bonded pair become closer to each other. This is why the bond angle decreases. Then if we have five pairs, there are four different situations. The first one, you could have four bonds and no lone pair. The shape will be trigonal bipyramidal, and this is going to be two bond angles. One of them is 90, the other one is 120. And then you could have three bonds and two lone pairs. The shape is going to be T-shaped, and the bond angle is around 88. You could say 90, they would accept it as well. And then you could have four bonds and one lone pair. This is called seesaw, and the bond angle, we have two different bond angles here. We have 87 and have 102. The fourth case for the five, if we have five pairs, is that you have two bonded pairs and three lone pairs. This is very common in the exam. So this is the central atom. There are two bonded pairs and we have three lone pairs. Then the shape is going to be again linear with a bond angle of 180. And then finally, if we have six, so we could have six bonds and no lone pair. It's going to be octahedral and the bond angle is 90. And we could have four bonds and two lone pairs. It's going to be square planar and the bond angle is going to be 90. How to predict the shape of the molecule? To predict the shape of molecule or determine the shape of molecule, you need to follow the following step. First of all, you need to determine or to find the central atom, and then you need to find how many bonds are there. So if we have something like hydrogen sulfide here, H2S, the central atom here is sulfur, all right? Because this is the atom where all the bonds are around, and we have two bonds around it. So first thing, let's look at the central atom. The central atom has six outer shell electrons because sulfur is in group self. So now the number of electrons in the outer shell is six. And then there are two bonds because there are two hydrogens. So we're going to add to the six two, which comes from the two hydrogens that make the two bonds. So in total, around the sulfur, there will be 8 electrons. Now we need to look at how many of these are going to be bonded pairs, how many are going to be lone pairs. So 8 electrons means there will be, we divide this by 2, there are 4 pairs of electrons. Okay, two of these will be bonded pairs because we have two bonds, and that means the other two will be lone pairs. So we calculate the bonded pairs, and the remaining will be lone pairs. So when we have two bonds and two lone pairs, the shape is going to be bent like water. So H2S is similar to water with a bond angle around 104.